Welcome to the demonstration of our tool, EvoMe, a software evolution management engine based on differential Factbase. Managing large and fast-evolving software systems can be a challenging task. Numerous solutions have been developed to assist this process, enhancing software quality and reducing the development cost. These techniques, for example, regression test selection, change impact analysis, and semantic history slicing, are often built as standalone tools, unable to share or reuse information among them. Differential facts introduced in our previous work enable the reusing of knowledge extracted from evolving software artifacts. The figure shows an illustration of the meta-model of differential facts, which demonstrates only a subset of the possible fact types. This includes the intraversion facts capturing the containment, calling, and referencing relations between code entities at the same version. There are also interversion facts which include the code-level insertion, deletion, and update changes between the old and new version, as well as the dependencies between commits. Concretely, such facts can be encoded in data log. To make the querying of differential facts more effortless, we introduce a SQL-like query language in EvoMe, allowing a large set of evolution management tasks to be specified with. EvoMe is a combination of the expressive intermediate representation provided by differential facts and the improved usability and efficiency supported by the newly added querying engine. EvoMe supports a SQL-like query language with cross-version support. It provides a language-neutral fact extraction, enabling maximal portability. A significant portion of the facts can be reused between iterative development cycles of the same task, and also among different tasks, thus making the query execution more efficient. With EvoMe, it is much easier for developers to do quick prototyping in order to try out and compare different new techniques. Now, let's take a look at the architecture of the tool. EvoMe provides a web interface, which receives the repository information and the query, and sends them to the Node.js server. If the repo is specified through an URL, the server will clone the repo through Git service to the server. The program fact extractor computes the program facts for the repository on selected versions. The fact files from each version are combined to form the fact storage. Meanwhile, the query file will go through a translator, which translates the EvoMe query into a set of Souffle programs. After that, the Souffle engine will analyze the generated Souffle programs against the fact storage, and a final output will be generated and presented to the user. EvoMe provides a web interface that looks like this. There are four main components: an input area that accepts a GitHub repository link, a drop-down list where a list of sample GitHub repositories are available, a code editor to input the EvoMe query, and a run button to trigger the analysis with GitHub repository specified and EvoMe query written. In this demonstration, we select one of the sample repos, Apache Commons Math, and we try to find the minimum set of test classes to rerun after changes between two versions. To break it down, we first search the calls to updated or inserted methods, and the caller should be a method as well. In addition, not only the direct calls, but all transitive calls should be included. For example, a method may not directly call an updated method, but it calls to a method that calls an updated method. Next, the caller is contained in a class. Likewise, the containment relationship should include the transitive containment cases as well. Finally, the class should be a test class, and we select the outer class name of such classes. We would like to highlight some of our syntax. Through the range statement, we can set different variables on different sets of versions. In the define statement, we support versional arithmetics in finding nth parents or nth ancestors. Through the method closure, we support finding a collection of transitive objects. After the Run button is clicked, the result is displayed as a table at the bottom of the web interface. In this case, there are two test classes that need to be rerun because they contain updated or inserted classes.